And here you go. So, welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC OEC. This year, our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers for 11 days. Also, it would be covering 4 different technologies. Please remember to register as many sessions as you can, and all sessions would be available to replay as many times as you want 2 weeks after the initial session's date and time. You can also interact with the speaker at any time during 2 weeks by posting questions or comments directly to the playback sessions page. With that, and we would like to thank you to all our uh, Oracle user groups, Java user groups to make this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. With that, for today's session, Robert Marz with us with JSON, the database and and without further any delays, I would hand over to you. All the question and answers will be taken at the last of the session. So over to you, Robert.
I'm here, yeah, of course.
Yeah, you can share your screen now.
Okay, here we go.
I'll be on mute.
Uh, it says I cannot share as long as you are sharing. So, good morning. And just in case I'm looking a little bit tired, that is probably because I'm living in Frankfurt, Germany, and Frankfurt, Germany is probably quite a little bit away from your time zone. Frankfurt is this beautiful city, and here it is 5 a.m. in the morning right now. Actually, we are in the autumn. The autumn just started. So these are the leaves like they are looking outside, and it's starting to getting cold in the next days. Okay, my name is Robert Marz. I'm an independent consultant. My primary role at the customer sites is a senior technical architect, where I have a very database-centric view of the world. Sorry, I'm an active member of DOAC, which is the German Oracle user group. And here I'm responsible for the cloud topics. I'm responsible for the cloud topics in the database community. I'm tweeting from time to time. This is my Twitter handle @RobbieDataB. This is my website, and I will upload the slides from this talk to this website as well. And if you have any questions about anything I'm talking today, please tweet me or drop me an email. This is my email address, and I'll do my very best to answer it. I am an Oracle Ace, and the Oracle Ace isn't a closed club, so you can become an Oracle Ace as well. If you are interested in joining the Oracle Ace program or know someone of who you think he should be inside the Oracle Ace program, just visit one of those links here, the acenomination.oracle.com or the Oracle Ace program, and probably we can meet each other in person when that's possible next time. Good. What am I going to talk today? I want to give you an overview of how to deal with JSON in the database. So all the use cases that are usually there, and all the questions that I've been asked by my colleagues about JSON in the database. I'm not going to be a better Oracle manual, so there will be no overview about all JSON comments with complete syntax diagrams or the evolution of those comments over the database versions. I leave that to the Oracle staff, and they can do that perfectly. Before we are going to talk about how to deal with JSON inside the database, we have to talk a little bit about this JSON guy. Who is JSON? So JSON is short for JavaScript Object Notation. It is a lightweight data interchange format. It is text-based, and it is a document format as well. So that means you can store JSON documents as files, and then you have a JSON file. It was originally designed to persist JavaScript objects, and that's where the name is from. And it has been standardized. So these are the two URLs. If you download the slides and click on those links, it will lead you directly to those web pages. So this the lower one doesn't mean standard not found, but the ECMA 404 is the official standard for JSON. Okay, JSON is a very simple interchange format. And it has to be, if we keep in mind that the original target audience for the JSON file format were people who thought of HTML as a programming language. So these are typically not programmers, they haven't studied computer science or whatever. And so JSON has been kept very, very simple. And that is good for us because it's very simple to understand, and that is part of the flexibility of the JSON interchange format. So we basically have two structures inside of JSON documents. The first is the unordered collection. These are key value pairs. Those key value pairs are separated by commas, and they are enclosed by curly braces. These are these curly braces over here. In other programming language, you realize those structures as object, as record, as struct, dictionary. So whenever you heard some of those terms in another programming language, this maps to an unordered collection in JSON. On the other hand, we have an ordered list of values, which again is separated by commas, and those ordered values are enclosed by square brackets. In other programming languages, those are called as arrays. The difference here is that when you compare JSON documents inside the curly brackets, the order of the elements can be chosen at random, and inside the arrays, the square brackets, the order is important. And we will see that later on in this talk in an example how that matters. Okay, so these are on the left side here you see a very simple JSON document with all the types of values you can have inside a JSON document. The mostly used value type is the string, and strings are always enclosed in double quotes. So you see these double quotes here. Then we can have numbers. Numbers don't need double quotes because they are a data type on their own. Numbers can come in different formats. You can use integers, floats, or the scientific notation with VE inside it. You can have a Boolean, you can use Boolean values, so true, false, or null. And of course, you can nest objects and arrays as you wish and need. So this is an example here for a nested object. We have a collection, and this is an example for a nested array. And inside this array, again, is an object. So we can make this as complex as we wish. There are a couple of things more to say about the JSON document format. First thing, the character set of JSON documents are by definition always Unicode. So this is always encoded in Unicode. And the next thing which is important if you live in a country like me that uses a decimal comma instead of a decimal point, the number encoding is in English format, which means we are using the decimal point. You can have as many white space. By white space, I mean space, line feeds, carriage returns, tabs, and so on, as you wish between the tokens. So the white space will be completely ignored, and you can structure and format your documents as you wish. There is no special data type for dates or date time formats inside JSON. So those dates are usually transferred or represented as strings. And it has been come to a de facto standard that we are using, the ISO 8601 Zulu time format, which I have given an example right here. So I try to guess the actual minute when I'm at this talk. So this should be the actual time string here. When I'm looking at the real clock, we are 1 minute or 2 minutes ahead of that. The ISO 8601 Zulu time format goes like this. You have the year, the month, dash the day, and then as divider a T for time, then the time in 24 hours format, followed by the time zone, that is in uppercase Z. And that one is really common if you're using date formats inside JSON documents. The last thing I want to mention is that JSON is a schemaless document format. So inside the original definition, there are no JSON schemas. That means every JSON document that is syntactically correct is a valid JSON document. So there are by default no schemas, no data structures you can validate JSON documents against. There are a couple of tries and things to standardize schemaing inside JSON, but they are not, they didn't made it in the official standard right now. So plain JSON document is always schemaless. Good. So now we know what JSON documents are. How do we store them inside the database? That's very easy because JSON documents are text files or just pieces of text. We can store them in any database column that accepts text columns. So we can use the varchar2 data type, we can use the clob data type or the blob data type. The blob is the preferred data type for storing JSON documents, because when you are using the blob data, the binary large object, you can the database can eliminate the NLS layer, the National Language Support layer, because the database knows that JSON is always in UTF-8 format. This works well since the Oracle 12.2 version, and especially if the database character set is set to AL32 UTF-8. You can put a check constraint on your JSON column. That check constraint name is called isJSON. If you put that there, the database makes sure that all strings, all JSON documents stored inside those columns are real JSON documents, and it enables the dot notation for querying, and we will see that in a second. And if you are happy enough to using the very latest Oracle database version, the 20C, which is available only in the cloud right now, there has been introduced a new data type, so the so-called binary JSON storage. And this is a brand new data type exclusively used for storing JSON data. It is way more efficient than storing those JSON documents inside text columns, and it is way more faster for querying. So it's probably worth having a look on that when the database 20 or the 21 database is generally available. Okay, so given we have a table called departments underline JSON, and we want to query the JSON values inside these table. So we have inside the table departments JSON a column called department data. That is that one here. And department data stores JSON documents. And one way to query that those JSON documents and extract values from those documents is to say select star from departments JSON, where JSON value from department data and $.department equals sales. If you imagine that you have lots and lots of JSON documents inside this table, you can imagine that that isn't the fastest or the most efficient way to scan those data. So a very good idea is to put a function-based index on this column. This is especially useful when you know that you are always searching for a specific attribute of your JSON documents. So the syntax of creating a function-based index looks like that. Create index name on my table, and then I'm just giving the JSON value expression here. There's an important thing, two important things to notice here. One is the error on error that makes sure that that errors are actually raised if something weird is inside the document, because if you remember, JSON documents aren't verified against a schema. It is possible that some very smart guy replaced the department field inside the JSON document by department array, by an array that is called department, and that would give very weird query results. So in that case, we want to have Oracle raise an error. And the other one is null and empty. That's clear what that means, that we are getting a null value when there isn't the field $department inside the JSON document. By the way, whenever I'm using an example with the table departments underlined JSON in it, I've took this example from the excellent blog post from Chris Saxon, how to store, query, and create JSON documents in the Oracle database. And I put the link to this blog post on the bottom of every slide where I'm using one of his examples. So if you want to know more about this stuff, just click on the link or Google Chris Saxon how to store JSON documents in the database, and you will find that blog post. Okay. The next option we can use to speed JSON searches up is we can create a search index. Search index are basically Oracle text indexes. Oracle text is a cost-based option, so you usually have to pay for it if you want to use it inside the database. But for the use with JSON documents, Oracle made it for free. And you tell the database that you want to create a JSON text search index by just using the keywords for JSON at the end of this statement. Those JSON search indexes can be used for the function JSON value, and JSON text contains for free text searches. You have to keep in mind that those indexes will become a lot larger than the function-based indexes, because it will index every document in every row inside your table. But once you have created a JSON search index, you can use this kind of statement here. You can say select star from departments JSON, where JSON text contains, and just searching the whole document for keywords. And that will be very fast after that, because it uses the well-developed and very good Oracle text option. Okay, so when do I store JSON documents? Well, that is answered very quickly. I'm storing the JSON documents inside the database whenever I need the original document. Whether it be for reference, for archiving, or for redistribution. So if I want to share the original document I just loaded inside my database with someone else. And there is another reason for storing those JSON documents inside the database is because remember, JSON structure may vary because they are schemaless, and there is the option that you probably want to query other fields later on. This is another good reason to store JSON documents inside the database. So since the Oracle database is a relational database, when do I convert JSON to relational data? Well, let's think about that. In my personal daily usage, I'm converting JSON documents to relations whenever I need to work with the contents, the actual contents of the JSON document. Remember, JSON is an interchange format, and that means almost always. So JSON is an interchange format. There's no real need to intensely working with JSON documents inside the database. You use it as an interchange, as an load the data into the database and convert it to relations and distribute the values on tables. That's what you want to do most of the time, probably. Okay, so how do I feed JSON to the database? So how do I load those JSON document files into the database? Let's have a look on that. First thing, we can use the insert statement. Remember, JSON documents are just text. So insert and update works fine as long as the document size is smaller than 4,000, or in newer versions, or if you have enabled the large varchar option, 32,000 bytes. And you can use the isJSON check constraints for rejecting non-JSON texts. I have an example on the left side on this slide here. So you can say insert into departments JSON. That's probably a typo here. There should be a space right here between the second JSON and values. And I'm using the util cast to raw function here because in my example table, the JSON store column is blob, and so I have to cast it to raw. Using that way, I'm bypassing all the NLS conversions, so I'm making sure that this document is stored the way it was retrieved. And again, I've took that from Chris Saxon's blog post here. The next option is I can use an external table or the SQL loader. Typically, we are getting JSON files or if we are getting JSON files from NoSQL databases like MongoDB or other ones, they are dumping those JSON documents in a special format where with one JSON document per row. And every time we have data files that are oriented one JSON or one document or one information per row, it's very easy to load it using the SQL loader or external tables. So I've given an example on the left side here. This is an external table, create table, table name with one column, the JSON document stored as blob, type Oracle loader, directory information, and just saying that the records are limited by the line feed. And that's it. This is my field JSON document. That is a raw column. And this is very fast loading of JSON documents inside the database because you can use parallel and all this kind of stuff that external tables and SQL loader scripts are capable of. Finally, there is another way if you are using a more modern command line tool like SQL-CL. SQL-CL, if you don't know what it is the SQL developer worksheet. So the actually text editor where you put in your statements inside SQL developer as a command line turned into a command line interface tool. The SQL-CL is very compatible to SQL+. but it is a modern command line interface. You have things like tab completion, a real statement editor, a history you can use, and a lot of enhancements over SQL+. And one of the coolest features inside SQL.cl, you can use different scripting languages instead of the SQL+ language. And there is every scripting language available that is implemented following the JSR223 standard. And just to give you a couple of examples, JavaScript is the default, but you can use Python and Ruby and all kinds of other languages as well. And there is an GitHub repository from the Oracle DB Tools development group that has tons and tons of very nice examples. And I've took one of those examples here and just compressed it a little bit. The original example would load a whole directory tree. This one here just loads a single file, and here with this little script you can load files from your client directly into the database if you are using SQL.cl. And I have an extra talk that is all around this scripting with SQL.cl. Not on the APEC tour, but if you Google, you will find, or if you go to YouTube, you will find a video I made for the ODTAC KSCOP conference this year. Okay, and finally, there is another way to get JSON into the database. We can very easily turn the database into a REST endpoint by using Oracle REST Data Services, which is called short OORDS or ORDS. ORDS is free. It is a small Java-based program, and it evolved from the Apex listener. So if you are using Apex, Oracle Apex inside your database, chances are very high that you have set up and installed ORDS already, and you can use it from right from the start. And ORDS very easy REST enables your database. You can, with a couple of clicks inside SQL Developer, REST enable a table. So provide a REST endpoint for a table inside the database. And the good thing, those REST services are pure metadata. You create them by calling a couple of PL SQL APIs, and you can develop and deploy one of those REST services within minutes. There's a very good blog post about that by Jeff Smith. Again, you can click on this link and it will show up. Good. So this is what it looks like. On the right side, this is a screenshot from SQL Developer here. On the right side, you see all that's needed in terms of PL SQL code. So all this very little, very simple PL SQL program. On the left side, you see the directory, the node tree of SQL Developer with the REST data services node opened. And basically, that's all you need to do. So you have to define, you have to give it a name, define it, say it's a post thing, and then you can use bind variables inside your insert statements to put JSON documents inside the database. So if you have set up a REST service, the clients on the outside can upload their JSON documents as they wish by using the service. And it works the other way around as well. Since Oracle 8, you can issue HTTP requests from inside the database. So you can make the database call other REST services as well. Very easy. The package is called UTL HTTP. Since Oracle 10 or 11, I think, you need to set up an access control list for allowing the database access the network and doing those HTTP requests. And if you want to use HTTPS, you need to set up a wallet for the certificates. But once you have set up all these things, it's very straightforward and very easy to implement, to call REST services and to implement a little package or a little PL SQL program that calls those REST services on the internet. I've done a talk about that stuff. It's called REST-DB links. And I have given that quite a couple of times. And there is a very good recording of this talk I have given for the OD talk code talk sessions. If you Google like that, you will find a YouTube video. Okay, so now we have stored JSON documents inside the database. How do I query them? And I need to query them when I want to distribute them, or when I into relational tables, or just want doing small small queries. And before we are looking on how to query those JSON documents, we have to look very short at the JSON path reference. JSON path is XPath, the XML path for JSON, and it is used all over the place inside the Oracle JSON implementation. It uses a dot notation, so you say dollar. The dollar sign is always the start of your document, or the starting point of your inside the JSON document, and from there you just describe your path through the document by giving those keywords from the key value pairs. JSON path returns JSON documents or single elements. And the good thing about that is there is a JSON path online evaluator. And oops, sorry. And I'm pressing just here. And you can see this is a live demo. You just enter JSONPath.com and you get this small website. The good thing about that is all happens in your client. So your JSON documents you are playing with never leaves your computer and your browser. It all happens in your browser. And you put the JSON document here. There is an example JSON document prefilled. This is on this side here. And you can just enter a JSON path expression. So by this is an example here by saying $sign is the start of the document. Go to phone numbers. Phone numbers is here, that one. Take the first element of the array and return the type of that. So this is the first array element, and the field type is an iPhone. Okay, let's see what happens if I'm saying, please give me the second one. Oh, no, this is, just give me the second one. We have no match here. Yeah, this is my home phone. So array starting, the numbering of arrays starting at 0 in JSON and JavaScript. So the first one will be 0. Let's see that. And yeah, we are getting an array back because those are all elements. If I'm putting the 1 again here, and let's give me the elements from 1 to 1. I'm getting the home. Let's see if this works with the age field. Let's just return the age field, and you can see as I'm typing, I'm getting the results displayed here. So if I'm just say dollar something, it is evaluated. The results are evaluated with every keystroke I'm doing. So if I'm typing first name here, I'm getting the first name. So you got the idea. This is very, very helpful if you want to build up your own JSON path expression, and you can put any JSON document inside just by copy and pasting, or we can even update that here. Let's type here John Doe, and you will see it changes as I'm typing. And you can copy and paste any JSON document. The size is only restricted by the memory of your browser or your computer where the browser runs in. So you can build up your expressions as you need them. Okay. The JSON path elements, I'm not going into details here, is very simple. We only have a couple of expressions here, and these are a couple of examples. If you want to dig into that, download the slides, have a look on those. And that's really all about it. There's not much more to know about JSON path. Okay, so now we know the JSON path language. Let's have a look on an example where it's used by using the dot notation. Remember the table departments JSON, and one important thing, if I want to use the dot notation, I have to use a table alias. So you see the yellow marked D over here. This is the table alias. You have to use that, otherwise it won't work. So let's say select D table name, department data. This is my column where I stored the JSON documents dot department, and here starts the dot notation. This is will make the Oracle database extract. This will make the Oracle database extract a part of the JSON document. And this is another example here. Let's see, I'm using, please return the first element of the employees array, and here the name. And this is what I'm getting the employee name value returned. And we have to speed up a little bit. So, and if I'm just saying, give me all elements, I'm getting an array returned here because there are more than one element. The important thing is that your JSON, that your column has to meets the is JSON constraint, or if you are using a database newer than Oracle 18, you can use the treat as JSON function. So you use that by using a with clause. You say, okay, with a JData, you're defining a virtual view here, select treat my column as JSON, and then the database knows that there is JSON document inside this column, and this is used instead of the is JSON constraint. Okay. The most important JSON function when querying JSON documents will be the JSON table operator. The JSON table operator lives inside the SQL from clause. It produces rows and columns. And this is a thing that's very rare inside the database. You can put in text documents and getting rows and columns back. It will accept lobs and JSON, lobs and varchar columns with JSON data, so it doesn't care if it's a CLOB or a BLOB or a varchar column. And the good thing about the JSON table function, it is included in the SQL 2016 standard. So other databases use it the same way. This is a very quick example. Here you are learning how to count to 6 in German. 1, 2, 3, 4, 5, 6 is 1, 2, 3, 4, 5, 6 in German. And this is how you use it. The JSON table operator lives in the from clause. The first argument is the JSON document, very simple JSON document, just an array. And the next argument produces the rows. So we are saying here, for every result, this JSON path expression returns will be a different row. So we're saying, okay, produce a row for every element inside this array. And the next part of the JSON table is the columns keyword. And here we can define all columns. If you want to have more columns returned, we just add them by via comma. And this one produces the columns of our result set. You can make this as complex as you wish. You can even nest those. Given the case that we have other JSON objects inside this array, we can even nest those JSON table things, and you can make it as complicated as you wish. But this very simple examples returns that, and that looks like every normal return when you are just when you are issuing a SQL statement. So this is how it works, and it is very fast as well. Okay. Remember when I told about the dates for the dates format. JSON dates are stored with ISO 8601 Zulu format, and you converting that to Oracle is tricky because Oracle, the to timestamp with time zone function, doesn't know about the Z keyword here. So what I was doing is I'm returning or I'm converting the string to a date back to a date. Then I have a date in UTC time, back to a string where I can add the correct timestamp, a time zone, the UTC information, and convert that back to a timestamp with time zone. So I have my date in the correct time zone. This is a little bit cumbersome and a little bit complicated, and even Oracle noticed that. So since Oracle 18, we have a new function that is called toUTC timestamp, and this makes our life very much easier because you can just enter those kind of strings and use it right away. Okay, so how do we work with JSON? If you want to compare JSON documents, there is the JSON equal function. And the JSON equal function really does a great job. What do you think the outcome of this statement is? So we want to compare these two JSON documents here. This one, 1, 2, 3, and that one, 2, 3, 1. These are two JSON documents, and actually those two JSON documents are equal, because if you are remembering the definition of the JSON file format, the order of the elements inside an unstructured the curly braces doesn't care. So I just changed the order of those documents and added a couple of white spaces here. And from the logic standpoint of view, from the results and the contents inside the JSON documents, those two JSON documents are equal. And imagine if you want to do this with regular expressions by yourself. Okay, and this is another example. Those two JSON documents really look very much the same, but they are different because the order of the elements inside an array is important. And in that case, those elements are, the order has changed. And so these JSON documents are different. Again, think about implementing that yourself, the comparison with regular expressions or things like that, and you won't be happy at all. There is a new feature, JSON merge patch in 19, in Oracle 19, and you can use that to update JSON documents inside the database to change the contents of the values. This works very simple. JSON merge patch. This is my document that I have, my JSON document, two fields, first name and last name. And if I say JSON merge patch and want to change the value of the last name field, it works as expected. So I'm giving another JSON document here with the contents I want to update. If I want to add another another key value pair, I just this is the same JSON document here, and I'm just giving JSON merge patch in JSON document with a field of the key value pair that isn't inside the document, and this field will be added. And if I want to delete one of those, I'm just doing that by giving a JSON document with the key set to null, and the result is a new fresh JSON document just with the last name in it. And I think I will need 2 to 3 minutes more because we are close to the end of time, but we are nearly done here. If you want to generate JSON documents, there are a couple of SQL functions starting with 12.2 with Oracle 12 CR2. So those functions are called JSON object, JSON array, and JSON array egg. If I'm saying select JSON object from a table, I will get a JSON object for every row inside my table here. This works very straightforward. If I want to have only a single document, single document returns for the things JSON arrays, I'm doing it like that. And if I'm using the JSON array aggr function, and this is an aggregate function, it returns me one single JSON document with every row inside my table incorporated. And this will look like that. So see the difference here. We have one JSON document that starts here with the square bracket and ends here with the square bracket. And because this is an aggregate function. And we can nest and mix and match those functions as we wish, and can that way use it to generate really complicated JSON structures if we want to do that. Okay, so how do I publish those JSON documents? There are a couple of options. The first thing, we can let the database write files to the file system by using UTL file. The drawback of this version or this variant is that we can only generate files and directories the database has access to it. So if our database runs in the cloud as an automated, autonomous database, that will be a little bit more complicated. We can use good old SQL Plus and just spooling those files outside by selecting with those JSON function and spooling it away. Or if you want to do it a little bit more modern, we can use SQL CL and writing a JavaScript script to just generate our JSON documents. But most of the time, we will do that here. We will use a REST service, because REST is the lingua franca of nowadays of modern web apps. And as I showed you before, we can use ORDs to implement a REST service. And that means we can let the clients request their documents on demand and deliver it via HTTP or the secure variant HTTPS. And so let the clients request their documents is the normal way the web works and web applications works nowadays. Okay, we are close to the end. Things I told you today was, what is JSON? How to store JSON content inside the database, loading JSON into, or when to store JSON content into the database, loading JSON into the database, querying those JSON documents, manipulating, updating JSON documents inside the database, and generating JSON. And finally, the publishing stuff. What I haven't talked about at all is the PL/SQL APIs that are there. There are a lot of PL/SQL APIs where you can use PL/SQL to generate JSON documents. I haven't touched them all. They are available in as well as DBMS packages, as Apex packages for generate JSON. There is a cool feature that is called JSON Dictionary. You can use that to let the database gather information about your JSON documents and provide that as views to add virtual columns to tables. This is very complicated and deserves a talk on its own. So you can't mention that or go over that in just the 2 or 4 minutes I have inside a talk like that. And the Apex JSON packages are part of the PL/SQL APIs. So and there are cool packages that working back with the older versions of the database as well. So those Apex JSON packages work with Oracle 10 and 11 as well. And those packages work from Oracle 12 onwards. Good. Only very few minutes over time. JSON is a very flexible interchange format, and it is the lingua franca of modern web apps. So nearly every web application is using JSON nowadays. Good for us, loading JSON is very easy because it's just text. The features of the JSON are evolving very quickly. So Oracle is doing heavy development on those JSON features. Think about the JSON dictionary or the 20C JSON data type. And you can turn the database very easy into the backbone of your RESTful services. And you definitely should do that. And please, please, please do try this at home and play around with those JSON features. And that's it. I'm done and open for questions.
Yeah, thanks, Robert. We have one question from participant, which is, what is schemaless?
A schemaless means, again, a schemaless means that if you are taking XML documents are usually checked against the schema. So you can give a structure and say, okay, an XML document has to have the right syntax. So it has to be a valid XML document, and it usually has to, the content of the document has to fit into an XML schema to be accepted. And you can use those schemas to sort out and to make sure that you are only getting JSON documents that that are matching XML documents that are following a given schema. So a data model, and so you can make sure that only given fields are inside this this document, or that some fields has to be inside the documents. And JSON doesn't have this at all. So if you are setting up one of those REST services, you have to make sure that you can deal with every JSON document, or with JSON documents that come with fields that you never thought about, that have different fields, that use those fields, key value pairs different, and because you have no chance to check the structure against the schema. That means schemaless, and this is gives you a lot of flexibility when you're developing, and a lot of trouble when you are working with third-party stuff and developers who are not tightly integrated into your organization. That means schemaless. Okay.
Thanks, Robert. With that, we will wind up the session, and thank you so much for joining this session. And please ensure you have other rest of the sessions for today joined, and there are many exciting sessions are happening. Thanks, Robert, for your time, and I know it's too early for you, but this was a great session. Thank you.
You're very welcome. See you, Ben.
See you. Thank you.